Project 1.6, the digital clock. Right here is a 24-hour digital clock. It has a switch to start the count, a potentiometer to change the brightness of the display, a button for the hours, and a button for the minutes. It also has a switch that can change the count to going backwards for setting purposes.
This is the original breadboard prototype. While a bit more chaotic, it functions the same as the finished version. As seen here, there's a potentiometer that can control display brightness, there's a button that can control the hours, and a button that can control the minutes. This circuit is powered by an NGO, or a NAND gate oscillator. This oscillator sends out the clock pulse, which is interpreted by the 4510 integrated circuits, which outputs a binary count. The binary count is decoded by the 4511 ICs and fed to the displays. The time is capped off at 60 minutes and 24 hours by using transistors. When the 4510s output a 4 and a 2, they are reset so that the count will not surpass 60. The same thing happens when the hours reach 4 and the 10's hours reach 2. With that, the prototype is capped off.
This is the soldered perma-proto version of the digital clock. Here are the interactive elements, along with the 7-segment displays and the power jack. They are on the top board so that they can be easily seen and interacted with in the wooden encasement. These are the 4511 ICs, and they run directly to the 7-segment displays through the use of resistors, which are covered in black electrical tape so that they do not bridge. On top of the bottom boards, there are transistors, 4511 ICs, 4510 ICs, and between the two boards, there's a NAND gate. Under the boards, there are plenty of wires and solder joints, along with an NGO, which powers the clock signal of the whole circuit. Finally, the circuit is held together by male-female headers, plastic screws seen here, 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 and on the rest of the board, and 3D printed skis, which hold the circuit up. Here is the wooden encasement. It was created by sawing an old wooden box in half using a Japanese crosscut saw and then gluing it back together. The first step was to unscrew the latch here and the hinges on the inside, here and here. Then the box was cut in half and the end was glued back together, as seen on this seam here and this seam here. The cutouts for the displays were made by a jigsaw, and the 7-segment displays here, interactive elements here, and the power jack here. Finally, the only thing to do is to put the circuit in the box. The circuit slides nicely into the top right corner of the box. The lid can then be closed and the latch can be put down. After the box is plugged in with the power jack, we see the clock turn on. Thank you for watching, and I hope you enjoyed.